Today we're going to talk about the geology of Hong Kong. Many people think of Hong Kong as being a bit of a concrete jungle, with visions of either the skyline of Hong Kong Island or Kowloon or trips up Victoria Peak. However, despite the dense population, there's also quite a lot of green space and some fantastic geology around Hong Kong. And some of those sites are flagged with the blue dots on this map here. Here's the geological map of Hong Kong. Most of it is volcanic and intrusive rocks from either the Jurassic or Cretaceous times. This means that instead of looking like this, it would have looked like this 200 to 65 million years ago. The only main rocks in Hong Kong that aren't volcanic or intrusive are these orange and beige rocks here, which are sedimentary rocks from about 416 to 250 million years ago. For this video, we're just going to be focusing on the volcanic rocks. Generally on the west side, they are Jurassic aged, whereas on the east side, where most of our sites are, all our sites are, they are Cretaceous aged. So they're somewhat younger in the west over the east. And one of the things will be one of the reasons to choose the east is it's near where a lot of the common tourist sites are in Hong Kong, but also it's where the High Island Formation is up here, which is a UNESCO geoheritage site. And then that'll be the first actual rocks we'll be looking at. So the High Island Formation is a uniform mass of crystal-bearing fine ash tuff, and the most notable aspect of it is that it forms extremely good examples of columnar joints.
So here is where we're going to hike, and the videos will come from these areas where we're going to walk down this road here, and then we're going to do a switchback and come back along the edge of the water. This is where we're going to see a sort of fold in the columns, and then we're going to walk over to this area here and have a little sea cave. And here we are at the High Island Reservoir, so we can see columnar rhyolite here as we go down the road. We're going to walk down this road and do another few videos down here. Now, how this is relatively rare to have columnar rhyolite, and how this formed was really quite large eruptions of a lot of ash material that's being blown out of the volcano we saw earlier, and then it's kind of coming together and cooling, and then it'll fracture into columns. At this location, we can see that dike that we saw further up the road on the switchback here, and you can see that it exists here, and it continues up beyond, so it's a really linear dike. I can actually walk down a bit more, go right in and strike, so we can see how they'd line up. And yeah, so this is basically a long strike, so the dike would go underneath my feet at this point. Here's the columns from another angle, so we can actually see the individual ones breaking off and kind of making clumps down the side instead of just the straight outcrop that we see on the edge here. So here we're looking at a curve in the columnar rhyolite. So this is a pretty rare thing to happen, and what must have happened, I read a few different things on how they think this formed. One is that there was some shearing that occurred before it was completely solidified, but after we had the fracture pattern. And then the other one was that it's due to gravitational compression of the rhyolite during cooling. You can also see that this weakness has been
exploited by this mafic dike that's cutting up through this curve. Here's a view back to give a little bit of a broader scale look at the outcrops that we just passed over. We can see the columnar rhyolites there in the distance, and we watch that switch back down. And then this is where the curve was due to possibly this slumping or compression of the columns during cooling. And then further down, we can see at the end of this trail, there's a nice little cave from broken down pieces of the columnar rhyolite. That doesn't go super far in there, but a nice little sea cave. Here we are looking at that same outcrop as the last one, or not outcrop, float. This is one of the columns, and we can see kind of large phenocryst, some of quartz, there's plagioclase, and then the odd one of potassium feldspar here. This is in a grayer matrix. It's probably more andesitic in composition than the other pieces. So it probably shows that there's a few different extrusive events here. As I pan out, you can see some of that hexagonal look of the columns, and that this rock formed from. So this is probably a cross section of one of the columnar rhyolites, or possibly andesites in this case, that we have here. Right, so here we are to the north of the dam, overlooking the reservoir. And you can see that we've got a lot of columnar rhyolite here as well. It's another nice outcropping where we can see these pretty plain columns. And you can see a few little curves that it's similar to what we saw further down the road. Another neat thing here is there's actually quite a few birds of prey that you might see as little dots that are flying in front of the cliff. So this is another nice outcropping that's on the way up to a lookout point where you can see a number of the islands that also have columnar rhyolite in them in the general area. So this is the type rhyolite from this sort of area, and you can see it is a little bit darker than some of the ones we showed you earlier. We have these pink alkali feldspar phenocrysts, as well as a few mafics, probably little, actually these might just be glassy bugs, as well as some quartzite throughout here. So this is showing that it's a rhyolite, slightly, because that's quartzite, slightly more mafic, but still light gray, as well as a fair amount of potassium feldspar within it.
Now we're gonna have move over to Shek O Beach and have a look at some of the intrusions over there.
Here we are at Shek O, or Shek O Beach, and you can see a lot of granite outcrops that pan across, especially here on the southern side where there's very steep granite bluffs. And then we'll go up and take a bit of a closer look at both ends. Here we are on the northern side of Shek O Beach, and if we look a little bit closer at the rocks, we can see that this is a fairly typical granite with decently large potassium feldspars, as well as abundant plagioclase feldspars. And in here on the weathered surface, it's a little bit harder to see, but there's still quite a bit of quartz crystals. So one thing you might note is that there's not a lot of mafics, the odd biotite clusters, but it's mostly a couple millimeter diameter plagioclase and orthoclase, and probably a similar amount of quartz. It's just a little bit harder to see on the weathered side of the outcrop. So this is fairly typical for this area. As you go closer to the interior of the intrusion, you'll get coarser grains. Yeah, now we're at the north end of the beach. Similar material. This intrusion is fairly extensive. You can see it's the same sort of material on the island across from me. And if we went further along the bend here, it cliffs out a little bit here, but you can get up on the road to the north and get onto a bit of a peninsula that has a bridge across it, and see more of the same material, and possibly seeing some coarser grain material. One thing we also get here is a number of thin quartz veins that are cutting through the intrusion. So you can see they're a couple millimeters thick, and they cut more or less all in the same orientation, sort of south by southeast across the intrusion. So here we are from the south side of the beach, and again you can see where I was a little bit before, just before it cliffs out about halfway over there. And again we can see a little island there. It's all this granitic material. And just below the cliffs that you can see there that we saw in the last video, and as we look closer at the rocks here, you can see that just generally it is coarser grained. So we can see a little bit more obvious some of these quartzites in here, as well as we're seeing more mafic fragments, probably biotites, and we're seeing kind of a bit coarser grain, so about twice the grain size as the last one. Fairly decent size case bars, probably 3 or 4 millimeters across, as are the quartz grains. He has a little bit more felsic over here too, and a lot of that white there is plagioclase as well. But one other thing that we see at this outcrop is we see some of these pegmatitic clots here. So we've got some pretty large quartz grains here, you know, a couple centimeters across, as well as plagioclase crystals that are about the same size. So this is probably closer to the center of the intrusion. And this may be also partially why the topography is a little bit more drastic here. We get a bit more cliffy, as well as another thing is we have fewer quartz veins. So it could be that it's a little bit more resistant because there's less of that fading and the alteration associated with it as well. So here we are just a bit further down beach from the last stop. And again, we're looking at the granite here. It's a little bit less mafics here. Again, we have got quite a bit of quartz, at least 40%, and more plagioclase grains. Pan over here, we're seeing again it's a bit coarser than it was on the other side of the bay, with probably 4 millimeter size crystals. Plagioclase a little bit smaller, but the quartz is fairly large here. And this is more or less what this intrusion looks like. One thing as I pan over that you would have seen before, we're seeing some hematitic weathering on the surface. Could be indicating that there's a little bit of pyrite in here, but not. But it also could just be mafic weathering.
Now we're going to go from Shek O and back into volcanic rocks and take a look at the Appalachian Formation at Ocean Park. And we'll have a look at that.
Right, here we are in Ocean Park, and there's a little bit of outcrop just about halfway down. You can see these long bands of dark rock within the fine grain kind of pale volcaniclastic. So these are big pumice fragments that have been altered to chloride. These are pretty common in this part of this unit, this formation. And there's some nice examples here. You can see up here, there's a little bit more. And as I pan across the outcrop, we can see more areas where we've got kind of the same thing. It's bleached, kind of rhyolitic tuff with these mats of pumice that have been crushed and that are all now altered to chloride. You can see it throughout this little outcrop here. We're even seeing a few little quartzites in here. It's not as crystal rich as it was down on the coast, but we can still see a bit more here. And here's another nice area here where we can see again these big class mafic beds, and you can see a little bit of bending in them that probably happened during formation. So this is actually pretty nice outcrop that is showing the nature of the formation in this area and some of the volcanic history of Hong Kong's past.
Now we're gonna go from Ocean Park and just head down the hill and a little bit to the west and have a look at some of the outcrops around Repulse Bay. And we're kind of in the south part of the bay.
Here we are on the eastern side of the Repulse Bay, and we're looking at the Applet Chow Formation. Excuse for the pronunciation. If we look this way, we're looking towards the west at Repulse Bay, and if I have a look, this is the lithology. So it's mostly a welded tuff. In areas there's fiamme as well as some lapilli. We don't really see it here. It's more just this pale tuff with some feldspar as well as some quartzite in it. You can see that it is fairly weathered here, and that's just because the exposure is not particularly great. But this is pyroclastic material that's from the Jurassic and fairly typical for this part of Hong Kong Island. And if we look out, we can see that there is some late veining here that must have been held some sulfides, because we're seeing a lot of hematitic and goethite staining on it. So again, we can have a look at this pyroclastic material. It's pretty well welded. And we have some of these fragments of feldspar crystals as well as some quartzite. This part is a little bit, has a slight greenish hue. This probably means that there was some fiamme here, as there tends to be some chloride alteration centered on the fiamme at this particular area.
Well, I hope you've enjoyed this brief introduction to the geology of Hong Kong. There's much more to see. Many of my choices were based around common areas for tourists or people to be visiting, and areas I was going on the trip. But also I wanted to highlight the UNESCO World Heritage Site at the High Island Reservoir. But please let me know in the comments if you know any other great places to see geology in Hong Kong, and I'll have a look next time I'm back.